Welcome to OpenFeature Summit. Usually I don't get to do the first talk of an event, but it's surprising. We'll be talking about a little bit of platform engineering today with OpenFeature. I started my journey with feature flags around 3 years, 2.5 years ago, back when I was at Harness. And they started off a little bit of platform engineering, so they asked me to do a CNCF webinar for them. And that's how I started learning about feature flags. But then after I did that webinar, I left the company. So eventually I couldn't do a lot with OpenFeature, but I have been following their community for a while now. And of course, every time we ship a feature, we open a new universe of complexity. And in this session, I'll be talking a little bit about that using OpenFeature and a new open source tool called k0rdent. But before that, let me quickly introduce myself. My name is Prithvi Raj. I'm a community manager and advocate at Mirantis. I'm also a CNCF ambassador. I started my journey with Litmus Chaos. That was a chaos engineering tool 5 years ago. And then that journey went on for 4.5 years. And then it's been platform engineering, k0s, and k0rdent for now, alongside all the activities I do around community, that is KCD Bangalore and platform engineering meetups on every Saturdays of the month. On the agenda aspect, I usually don't like adding an agenda. I believe that let's keep it, let's keep the flow as it goes, and you can stop me when you want. If you feel I'm just speaking jargon, or once I get a time check, I would just want to stop. But I see a few folks in the room. Let me quickly ask you, how many developers in this room? Like, I see 20, 25 folks. Okay, I believe most of them, all of them are developers. And because it's the first talk, or else I thought I'll just skip the slides. I guess you folks might have attended a few co-located event sessions. But I'll start with a metaphor. And this is hello in 100 languages, an expectation from developers. If I have to translate it into CNCF terms, this is how it looks like. I mean, developers are asked to learn a lot of tooling. They are asked to learn runtime, service mesh, chaos engineering, incident management, monitoring, logging. And that has created a gap between what the developer exactly wants to do and what the developer eventually is doing. Developers are forced to learn a lot of infra, and that has led to, a cognitive overload. Developers don't want to write code, or eventually, of course, they are not able to reach where they want to. And if I have to talk about how cloud in itself started, the idea was to have a data center interact with the public cloud environment. But this is what we have been subserved with, where people are on infrastructures with multiple APIs under the hood. There's no one single cloud environment or Kubernetes cluster or Kubernetes environment where they are able to host their infrastructures. And basically, we are having a battle between proprietary vendor stacks and multiple public cloud, private cloud environments to drive your infrastructure, especially in the large organizations. And that is what led to the struggle of navigation. Although the idea of Kubernetes in itself was to make things simpler, Kubernetes became the orchestrator or the scheduler that will help make things simpler. And Kubernetes, of course, has matured, and that is why the CNCF ecosystem has developed. But it has led to another problem in itself, where people are using Kubernetes under the hood of their clouds and infrastructures. But again, there are multi-cloud, multi-cluster environments and so many APIs under the hood, which are basically not able to streamline things or let people use Kubernetes the way it should have been. And the idea is to have Kubernetes as the common control plane. Obviously, modern Kubernetes becomes easier, and the idea is to have a thin layer of Kubernetes that will let you use these cloud services, infrastructures in a simplified way. And that is what the idea was. I know there are a lot of proprietary solutions out there. But I believe with the CNCF ecosystem developing and with feature flags in itself becoming an important aspect of the platform engineering ecosystem, I see the future of intelligent operations somewhat like this, where even if you are using your Kubernetes environments with Kubernetes as the common control plane or the super control plane, and then you have your AI Kubernetes hosted on GPUs, or your MCP servers driving a lot of your operations. Feature flags are going to be an important aspect driving these platforms. And the question is, if your features were universes, who's managing the chaos? It's not the deployment that's hard anymore. It's managing what happens after the deployment. Different clusters, different environments and teams lead to the feature drift and say a configuration chaos. And that is where we identified 3 important challenges, not in just terms of your platforms, but also, bringing in this aspect of feature flagging in your platforms. The 3 critical aspects that we see, of course, the technology stack complexity, which I spoke about. AI projects are taking too long, and of course, I believe every other person I meet today, I asked them, what are you up to? What are you working on? And they said, I'm working on AI. I'm working on implementing AI in my Kubernetes environment. So that's the reality. We have to face it. There's like a tenant isolation, skill gap, innovation in itself. Customer experience, again, you have eventually, if your company is not making money, or if you are not satisfying your customers or having a customer base, you will not be able to work on your side project or what you want. So of course, if you want a familiar experience like what hyperscalers have, you need to expect that you have a multi-tenant environment. Your customers expect a turnkey ecosystem that just works. And of course, with low latency, high reliability, and eventually, you are able to reach that operational efficiency, which is able to maximize your ROI. And as I said, multi-tenant in nature in itself. That leads to a case of a new approach. I mean, Tocket being a better way. Traditionally, feature flags were used by developers inside application code for conditional logic. It was seen as a boolean or a toggle. But in the modern platform engineering era, feature flags have evolved into platform primitives. I mean, they are treated as infrastructure level abstractions. Feature flags now are living alongside infrastructure as code. I have seen people deploying feature flags alongside crossplane. They are being managed declaratively. People are participating in multi-cluster policy enforcements. And of course, you are feeding it into OpenTelemetry or your Grafana dashboards or whichever observability tool you're using. So is platform engineering the solution? I'm not sure how many talks we have seen with OpenFeature and platform tools, or say Backstage or the other platform tools out there, because I was going through a lot of OpenFeature Summit talks over the past, but I couldn't find such a topic. I believe platform engineering is not a new concept, but platform as a product is a newer, more strategic mindset, which defines that you are not just serving a platform, but you are also serving a product for users with feedback loops and measurable value. And it has certain key characteristics, of course, an ownership mindset. You have a user-centric design, some principles. Maybe in Europe, the DORA metrics have been pretty popular, or the NPS, which are being applied internally. And that is where we identified a problem, which I have coined as the multiverse problem: infinite clusters, configs, and headaches. In today's cloud-native world, we are not just deploying software, as I spoke about. We are deploying universes. Every environment, cluster, team, becomes its own little reality. And the problem is each universe starts drifting apart. Different configurations, flag states, environments lead to entropy and eventually chaos, where feature flags were meant to bring in safety. But without consistency, they can just create fragmented realities. And that is where the developer ecosystem is struggling. the code is stuck in review, the deployment is error prone or slow, branches are getting larger and larger, the device config system is native, perhaps the global config system is offline, confusions, duplications, lack of guidance. And that is where I have seen a lot of feature flag implementation being self-served or DIY in nature, but it has its own risks, or I feel additional maintenance, cost. There are hidden costs, of course. It seems it's cost effective, but the risks can lead to significant long-term expenses. Security risks, again, can grow. There's a resource demand, developing and maintaining in-house feature flagging systems, manual configuration and deployments, customer support or technical debt can increase without centralized data access. And that is where I just wanted to give you all a reality check that feature flags are easy until Kubernetes multiplies them. In a single cluster, you flip a flag, but if you have multiple clusters, you need therapy, or staging says the flag is on, production says it's off, and your observability dashboard says maybe. So let's enter into the Featureverse with OpenFeature. Although if my talk would have been the second or the third talk, I wouldn't have introduced a lot of OpenFeature. Todd already did it for us, but I believe it's a very it's a popular CNCF project. It has stepped into this world with a universal API and standardizing how you evaluate your flags, no matter which provider or backend you use. Obviously, FlagD has been very popular. I've seen folks using it with Launch Darkly as well. But in my Featureverse analogy, OpenFeature is the portal key that lets every app speak the same flag language. And what is the value of a feature-native platform approach? I believe it's pretty readable. I won't take a lot of time here, but it has helped platform engineers and development teams build new applications with minimum toil, enabling feature flags in the right sense, delivering the use case optimized IDPs, and of course, ensuring better reliability, better features being served. And what are the key requirements before we go on to the use case, or before we go on to the aspect of how we deploy our open feature use case? You need to ensure that your features are manageable. You are able to improve them with time. You are able to write the right code while you are deploying your feature flags in a runtime environment. You have to get the metrics in place, the right observable architecture. You need to ensure that they are controllable. Of course, I have spoken about it. And then performant, I think we'll speak about how the performant aspect looks like it in terms of open feature in itself. So before I start my use case, let me introduce the other half of this talk, the other tool that we'll talk about. And that is basically an enhanced version of not just a cluster API, but also an enhanced version of an instrumented cluster API with a state manager, with a resource optimization, and obviously observable in nature. And that is where I introduced to you k0rdent. It's an open source tool that went GA this February. The idea was to ensure that you are able to manage your multi-cloud, multi-cluster environments the right way. It uses cluster API under the hood, and you can manage it, your different cloud platforms, even if you're on AWS, Azure, GCP, or your public cloud environments, edge environments. So you are able to manage it easily. And then, of course, it uses another open source tool, which is Project Sweltos, to manage your add-on controllers, to manage the different states of your system. It uses OpenCost under the hood for your resource optimization, and then it uses Victoria Metrics, OpenTelemetry, and Grafana for your observability stack. So this is a little bit of the architecture. I hope everyone is able to see the architecture. It uses the KCM controller, which is the super control plane, which is managing your different environments. And as I said, it is using the cluster API under the hood. So if you are having, say, an Azure environment, so it uses the Kappa controller or a KAPZ controller. And then it also has the Swelltoss controller, which is managing your beachhead services, say your Orgo CD or your ingress controller, your service mesh. And it's again having a kickoff agent as well, which is managing the resource optimization side of things. I won't take much time because we have a use case to talk about. But it works on a predefined service template model. So basically, all the templates that you are utilizing are repeatable. You just have to pull in a template, which is a YAML file, and you can use your cert manager, Cilium, your CSIs, Flux, anything pretty easily. This is how a template looks like. The idea for us is to create an open feature template in the future, which we'll donate to the k0rdent catalog itself, which is an open public place market for you to use these YAMLs in a repeatable form. And this is how a service template looks like, which is what I'm going to commit at Open Feature Summit, that we are going to donate an open feature template to the service template in itself. So let's look at a use case where your open feature and k0rdent collide. Together, open feature and k0rdent can create a feature ops pattern. That is what we believe, where feature states are versioned, governed, and automatically reconciled across environments. Developers define feature intent in their Git repos. Flux reconciles that intent. k0rdent enforces policies and observability, and open feature connects the app to the flag state. So the idea is open feature plus k0rdent represent a modern platform for managing feature lifecycles in Kubernetes platforms using GitOps principles. So open feature provides a standardized language agnostic API in defining feature flags across applications, and then developers declare the feature behavior, integrate it to, say, a flag D to dynamically update the runtime states. And then it abstracts feature logic from feature operations, letting teams focus on intent and not infrastructure. And then k0rdent, which is already having Flux under the hood, uses the GitOps principles to reconcile configurations and flag states declaratively. It enforces rollout gates, manages placement across different clusters, and integrates it to your telemetry data to ensure that you are able to visualize what's happening in your systems. And the idea behind feature ops or GitOps-friendly feature ops is we are creating a workflow where developers are managing features declaratively. Flux plus k0rdent automatically applies, monitors, and enforces these changes across clusters. And you use OpenTelemetry to provide continuous feedback on rollout performance. So in short, open feature handles the what, feature intent. k0rdent handles the how, deployment policy and safety, and together they make a Git-driven, automated, observable, a true feature ops model. So let's look at a developer's point of view. From a developer's point of view, managing a feature is no longer about flipping switches in code. It's about committing intent to Git. With open feature, developers can describe flag states. Flux ensures those definitions get reconciled. The flag D sidecar keeps the app updated in real time, and the open feature SDK handles the evaluation logic. From a platform point of view, if we switch perspectives, developers who are writing code to the platform engineer who keeps everything stable, for a developer, a flag could be a toggle, a boolean. But for a platform engineer, it represents an operational event, and that is where k0rdent is coming into play. It brings the idea of policy-driven feature management, as I spoke about. And in short, where developers are driving velocity, platform engineers will maintain stability. And that is what we have derived in a DevOps ecosystem, the Featureverse engine. As I spoke about, the developer commits a flag change, Flux syncs the config, the flag D updates it, there's a shift in the application behavior, and then you are able to visualize the telemetry updates in Grafana. That is how we have summarized it architecturally, as I spoke about. Uh, this is how the possible architecture looks like on how you're going to deploy feature flags in a platform engineer's environment, or using your internal developer portal. And if I talk about the future, what's the tomorrow looking like? It's of course, as I spoke about, agentic in nature, agentic feature ops. We are trying to add a thin declarative layer around any MCP server, and that is where the next roadmap for k0rdent is adaptive ops. That is basically adding a clean abstraction to connect your gateways, registries, LLM routers. So the next aspect of the Featureverse mostly looks like, platform isn't just declarative, but reflexive in nature, where your telemetry data and your AI agents are collaborative in nature to make your real-time decisions. And that is where the MCP adaptive ops comes in. And that is where we see OpenFeature contributing, or the implementation of feature flags in your platforms. And I've taken an example of how a platform looks like. This is a simplified example of a developer platform where I have used different tools for different aspects, say k0rdent for your policies, cluster API or Rancher for managing, you're using Cilium or your Nginx, and then you're using Prometheus, KubeCost. But how you implement your IDPs using k0rdent and OpenFeature somewhat looks like this. You integrate k0rdent into you integrate feature flags into your k0rdent templates. Basically, what you're doing is adding a service template to extend your cluster template, deploying flag_d or any other flag provider, of course, as part of your runtime services. You introduce your YAML parameters in your template for flag config, use the GitOps flow as we spoke about, and then add a service template for the SDK side of things. And then you can, of course, optionally enforce, say, an OPA or a k0rdent to control the rollout exposure and enforce observability before allowing full exposure. So to conclude, we spoke about the new approach and how the current approach and the modern platform approach looks like for us. Of course, the current ownership is developers, but the idea is to have shared ownership between developers and platform teams. Perhaps a lot of folks who are implementing feature flags have ad hoc toggles in place, but the idea is to have it in a declarative way, in a GitOps way. The scope isn't just an app-level scope, but a multi-cluster, multi-cloud scope. You have to make it policy-driven, and the eventual idea is to have the MCP adaptive ops to make it more AI-friendly and AI-assisted. So in conclusion, the biggest takeaway that I have is feature flags are part of your infrastructure, not just app logic. Treat them as part of your platform. So here are 3 core lessons we have learned through the Featureverse. They are declarative in design. Don't treat your flags as toggles hidden in your code base. Observable by default, of course. Every feature flag should leave a trail. OpenTelemetry is the best integration that you can use from that aspect. And policy-driven in multi-cluster, multi-cloud environments, you need automated safety rails, and that is where k0rdent comes in to ensure that you are, preventing unsafe rollouts. So I believe I just finished in time. And thank you so much, everyone. This is the GitHub link for k0rdent for you to check out if you are implementing a multi-cluster, multi-cloud environment, and then you implement OpenFeature as your API to drive your feature flags. This is how you can get started. Thank you, folks. Thanks, everyone.